Hello, I welcome you to Let's Learn, and in this edition, we'll be solving questions prior to the last edition. Let's start. Let's find the members of M, N, and K using the Venn diagram. So let's start with M. We have P, we have U, we have T, we have Z, and we have R. With N, we have R, we have Q, we have V, we have Z, and that of K, we have T, we have Z, we have V, we have S, and W. Let me show the Venn diagram again. We have M and K, and you have the outside ones, that's Y, X and Y, sorry. You have P, U, T, Z, R, V, Q, S, and W. Let's list the inverse assets, of which we have P, Q, R, S, T, U, V, W, X, Y, and Z. As you can see in the Venn diagram, we have a certain portion here where we have X and Y. They are not part of either M, N, or K, but they are in the inverse assets. So therefore, we can list their members, their elements, to be a member of the M union N union K all prime. This means that when you unite that of M, N, and K, you won't find any of them. When you unite them, these are the two elements that will be left in the inverse asset. So therefore, let's find M prime. M prime are the members of the universal set that are not elements or members of M. So let's see those that are not members of M. We have P. P is a member of M. Q is not. So we have Q. R is a member of M. S is not. So we have S. T is a member of M. U is a member of M. V is not. W is not. X is not. And Y is not. Let's find N prime. These are the members of the universal sets that are not found in the members of N. So in the members of N, we don't have P. So we have Q takes it away. We have R takes it away. We don't have S. We have T. We don't have T in that of the N. We don't have U. We have V. We don't have W. We also don't have X, and that of Y. K prime. That's the members in the universal sets that are not part of K. Let's find the element of K prime. And the elements of K prime are the members that are not in this circle that belongs to K. So therefore, we have Q, we have R, we have P, we have U, we have X, and we have Y. So the K prime is equal to P, U, R, Q, X, and y. With this, we can start with the solving of the questions one by one. So let's start from A. We have AI. We have to find the members of M intersection N or union K. Whereas we have M intersection N. M intersection N. To be M intersection N, we have R and Z. So we have it to be Z R or RZ. So anyway, write it. So now we unite it with that of K. So therefore we list the members of K adding the Z and R. So we have the answer to be M intersection N or union K equals, we have T, Z, we have Venn, we have S, we have W, and we have R. II. We have M union N or prime. So we have to find M union N first. So we have our M union N to be, we have P U R Z T V and Q. Let's see. This is M union N. Therefore, we have P U T Z R Q and V. Now we have to find the prime. The prime are the members that are outside that of those two. So we have X, Y, S, and W. So we have M union N or prime equals S, W, X, and Y. I. We are asked to find M intersection N or intersection K. This is the same as M intersection N intersection K. Therefore, from the look of this, the M intersection N intersection K is Z using the Venn diagram, since that is the only alphabet that can be found in N, M, N, and K. So we have the answer to be, that's M intersection N intersection K to be equal to Z IV. They are asked to find M intersection N intersection K prime. So we have M and N. M intersection N intersection K prime. Whereas we had our M intersection N to be Z and R. So we have to intersect it with this K prime. When we intersect it with the K prime, the only figure here that is found in both sides is the R, So therefore, M intersection N or intersection K prime is equal to R. Then we have M intersection N prime intersection K. M intersection N prime. So we have our M to be here. Intersection N prime. N prime is these members, the members that are not part of N. So all these members are not part of N. So if you are finding M intersection N prime, they are P, U, and T. So M intersection N prime is, let's write the letters U and T. Intersection. We have M intersection N prime. We had it to be P, U, and T. So now we intersect it with that of K. And if you are intersecting it with K, the only alphabet we get is a T. Let's move on to the next. That's Venn, where we are asked to find M prime intersection N intersection K. we have our n prime to this. So now we intersect it with n. If we intersect n prime with n, the value we are going to get is Q and Venn. Since within the members of M, they are R, P, U, T, Venn, and R, and that of N is R, Z, Venn, and Q. Sorry. So if we are supposed to find the prime of N, those are this, and if we are supposed to intersect it with that of the values of N, so they are Venn and Q. So M prime intersection N is equal to Q and Venn. So now we intersect the Q and Venn with K. If we intersect the Q and Venn with K, the only value we are going to have here is a Venn, since that's the intersection side. So we have M prime intersection N in intersection K is equal to Venn I. We are asked to find M union N intersection K, where N intersection K is Z and Venn. So we have Z M union, that's Z and Venn. So since we are uniting it with that of M, we have to add the Venn to the member of M, since the M has a Z already. So let's list that's M union bracket between N intersection K equals P U T Z R and Venn. Let's move on to Venn I. M intersection N prime intersection K prime. So let's find for M intersection N prime. M intersection N prime. So we have our N to be P, U, T, Z, and R, and the N prime is P, S, T, U, W, X, and Y. So M intersection N prime gives us, we have P, U, and T. So now we have to intersect it with K prime. So when we intersect it with K prime, the value we get is P and U. Let's move on to B. In B, we are asked to find for that's M union N all prime intersection K. Okay. B, we are asked to find M union N prime intersection K, and the M union M prime is equal to S, W, X, and Y, as we can see. Using the two circles of M and N, the outside figures we have X, Y, S, and W. So therefore, our M union N prime is equal to, we have X, Y, S, and W. Whereas we are intersecting it with K. So the intersection is going to be S and W. So we write M union N prime intersection K is equal to S and W. Question 2. Let's first list our data down. We have the student. Let's represent the data. So we have student that study history let's represent it by H, science S, and geography J. We have all three, that's H intersection S intersection J, to be equal to 7. We have H intersection J equals 11. We have J intersection S equals 9. We have H intersection S equals 10. We have history to be 34. We have geography only, so only to be 18. We have science only to be 16, and we have none of the three, so H union S union J all prime equals 3. So let's represent it in the Venn diagram as it says in I. We have H 34, we have S, and we have our J. Since we were given all three is 7. We have H intersection J, that's 11. But since they didn't say history intersection geography only, we have to subtract the 7 from the 11 to get history intersection geography only. So when we subtract this from the 11, we are going to get 4. And history intersection science, we were given to be 10. If we also have to subtract it to get the only, so we get 3. And that of science intersection geography 9, we subtract, we get 2. We have geography only. Geography only is 18. Science only is 16. Let's represent the history only by an A. We weren't giving U, but let's write our U. Let's move on. Sorry, this was I. We are asked to find for history only. Therefore, history only. Our history only was represented by A. So if we are supposed to find for our history only, the only way to find it is equating that of the circle to the total, that's 34. So we add A plus 4 plus 7 plus 3 and equate it to the 34. So now we have A plus 3 plus 7 plus 4 is equal to 34. So A plus, we have 14 is equal to 34. So we move the 14 to the other side. We have A equals 34 minus 14. A equals 20. In the I we are asked to find the number of students that are in the group. So if we are finding for the number of students that are in the group, that means we have to add all the members in the group. So we add from A 4, 7, 3, 16, 2, and 18 to get the universal set. So let's add them. Let's first write total students. So we have A was found to be 20. So 20 plus 3 plus 7 plus 4 plus 18 plus 2 plus 16. Sorry, I left something out. That's the 3 here. So plus the 3. So the sum of all these numbers gives us 73. So we have the group contains 73 students. So group contains 73 students. We have how many students like exactly 2 subjects. So exactly 2 subjects is represented by this side, because this side shows 3 subjects. So if they say exactly 2 subjects, you are not going to pick only one of it. You have to add this side, and that of this side. So exactly 2 sides. Exactly 2 subjects, sorry, not sides. So exactly 2 subjects, we have 3 plus 4 plus 2, which gives us 9. So therefore exactly 2 subjects is 9 students. 9 students. Question 3. In question 3, we were asked to find A. Question 3, A. We are asked to find the elements of set A, B, and C. So A. We are asked to find the elements of set A. Let's start by set A. Whereas we have set A to be the multiple of 5, of which the universal set was given to us as 1, 2, 3, up to 20. So the range of elements that are multiples of 5, that's set A, should be between the range of 1 and 20. So let's see. We have 5, 10, 15, and 20. B. Just as I said for A, B is a multiple of 4. So therefore, the multiples of 4 should range between 1 and 20, since that is the beginning and the end point of the universal set. So therefore, we have 4, 8, 12, 16, and 20. The last, that is C. C is also the multiple of 3, just as I said, ranging between 1 and 20. So we have 3, 6, 9, 12, 15, and 18. B asks us to find I. A intersects B. So let's find A intersects B, since we have both A and B here. We don't have 5 in B, we don't have 10 in B, we don't have 15 in B, we have 20. So the first one is 20. We don't have 4 in A, we don't have 8 in A, we don't have 12 in A, we don't have 16 in A. So therefore, the intersection of A and B is 20, since it's found in both of the sets. So intersection of A and B is 20. We have II. A intersection C. A intersection C. We don't have 5 in C, we don't have 10 in C, 15 is in C, 20 is not in C. We don't have 3 in A, 6 in A, 9 in A, 12 in A, we have 15 in A, and 18 is not in A. So our answer for A intersection C is 15. I. We have B union C. With B union C, we have to combine the element of B and C. So we start from the smallest to the biggest. We start with 3 and move on to 4, 6, 8, 9. We have 12, 15, 16, 18, and 20. So let's write them. We have 3, 4, 6, 8, 9, 12, 15, 16, 18, and 20. C. Using the results in B, we are asked to find A intersection bracket open B union C equals A intersection B union A intersection C. So let's solve it. We have B union C here, and we have our A here. So now we have to intersect these two. Intersecting these two, let's see. The members of A is 5, 10, 15, and 20. That we are intersecting with B union C. So we have 3, 4, 6, 8, 9, 12, 15, 16, 18, and 20. That's A intersection bracket B union C. What's the intersection here? We are going to get, there's no 5 in that, no 10, we have 15 and 20. So that's A intersection B union C equals 15 and 20. Now we move on to the next. That is A intersection B union A intersection C. What's A intersection B? We have 20 for that, and we have 15 for this. We are uniting them, so therefore this gives us an answer. That's A intersection B union A intersection C equals 15, 20. So this proves that A intersection B union C is equal to A intersection B union A intersection C, since both of them is equal to 20, 15 and 20. Question 4. Let's jot the data down. We were given our universal, that's the number of travelers, to be 22, of which 12 of them have passports. So passports represented by P is 12. Health certificates each is 14. And we have currency, the amount of money they are saying is 11, represented by a C. 6 of them have both passport and currency, so P intersection C equals 6. 6 of them has passport and certificate, so P intersection H 6. And 7 of them have a certificate and a currency, so H intersecting C equals 7. The A axis 2 represents this information on a Venn diagram. So let's draw it on a Venn diagram. You have P, you have H, and we have C. Our U22, P12, H14, and C11. We weren't given the intersection of all of them, so that's X. We were given PC. PC was given, the PC that was given shows this side. So if you want to know this side, you would have to subtract the X from the PC that was given. That was 6. So we will get 6 minus X. We were also given PH. And also, since only wasn't added, it means the PC that was given was this side. So we also have to subtract the X from it, making it 6 minus X. Lastly, HC. The same way. Since only wasn't added, it's all this side. So we have to subtract the X from the 7 to get that side. We have 7 minus X. P only, H only, and C only weren't given. So we can represent them by an alphabet. That's A. This is B, and this is C. We are asked in B to find X. That's all the 3 requirements. They have all the 3 requirements. That's the passport, the health certificate, and that of the currency. So in order to find it, we have to know A, B, and C. Knowing A, B, and C, let's find it. Since we were given the whole of this side to be 12, we can add them and equate it to 12. So we make A the subject. Let's solve it. So we have, for the P, we have 12 is equal to A plus 6 minus X plus 6 minus X plus X. This is the first 6 minus X, the second one, and that's of the X. Let's add them. This X takes this X away. We now add the 6 to this one. So we get 12 equals A plus 12 minus X. Since we are making A the subject, let's move both 12 and minus X to the other side. So 12 minus 12 plus X equals A. 12 minus 12 goes away. Now we have A is equal to X for the P. Let's move on to H, finding B. So we have 14 is equal to B plus 6X plus X plus 7 minus X. That's this, and this. Now 14 is equal to, this X takes this X away, since negative X plus positive X gives us 0. So 7 plus 6 will give us 13. So we have B plus 13 minus X. Remove the 13 and minus X to the other side. So 14 minus 13 plus X equals B. Whereas we have B to be equal to X plus 1. C. We are also finding for C again. So we have 11 is equal to 6 minus X plus 7 minus X plus C. 11 equals, this X takes this X away, since negative plus positive gives you 0. Now the 6 plus the 7 also gives you 13. So we have 13 minus X plus C. Remove the X and the 13 and the minus X to the other side. So we have 11 minus 13 plus X equals C. We have C to be equal to minus X minus 2. The B asks us to find all the 3 requirements, that is X. In order to find for X, we needed the A, the B, and the C. Since we have found it, now we represent the A by the x, the B by x plus 1, and the C by x minus 2. So if we have it, that means when we add this portion, this portion, this portion, this portion, this portion, this portion, and that of this, it is supposed to give us 22. So let's do it that way. So we have B high. So let's start with the A. A is x. So x plus 6 minus x. B is x plus 1. Then we move on to plus 7 minus x. We have C to be x minus 2 plus 6 minus x plus x. The middle one is equal to 22. Solving it, this x, this positive x takes the negative x away. That of this takes this away, and this one also takes this away. So now let's add the numbers. This maintains. So we have x plus, we have 6 plus 7 is 6 plus 1 first. We have 7. 7 plus 7, we have 14. Now we subtract 2 from the 14 to get 12. Then we add the 6 to it to get 18. So x plus 18 is equal to 22. So x equals 22 minus 18, where x gives us 4. So therefore, all the three requirements the number of people that had all the three requirements equals 4. Let's find that of A, B, and C. Since we have the value of x, A was given to be x, and since x is 4, we have A to be 4. B is x plus 1, and since x was given as 4, we have 4 plus 1. That's 5. So B equals 5. C was given to be x minus 2. Since x is 4, we have 4 minus 2. C is 2. Let's fix all this into the Venn diagram. So we have we have P 12, H 14, C 11. We have our H to be what? 4. Our A to be 4, B to be 5, C to be 2. Now we have to subtract the 4 from the 6 in the first diagram that we drew. So we have to subtract it. 4 from 6 gives us 2. 4 from the 6 that was here, this whole place was 6. So we had to subtract the x from the 6 to get this portion. Now we subtract the 4 since we know it's the x, so we also get 2 here. Here, the whole of this side was 7. So if you subtract the 4 from the 7, we get a 3. We have our U 22. The we were asked to find exactly 2 requirements. And if you are asked to find exactly 2 requirements, it means the sides of which they intersect. Not all the 3 intersect, but only 2 intersect. For example, we have P and H intersecting at this side. That's 2. P and C intersecting at this side, that's 3, and P and C intersecting at this side, that's 2. So we add these portions, 2, 2, and 3. So exactly 2. Exactly 2 requirements equals 2 plus 2 plus 3, which gives us 7. So therefore, the number of people that have exactly 2 requirements is equal to 7. This brings us to the end of this edition. There's a number 5 I would love you to try your hands on. Since it's similar to this question, it will give you more knowledge about solving these types of questions. And this brings us to the end of set 2. I know you loved it. Thank you. Bye-bye.